Hello, my name is Robert Walker, and I'm going to talk to you today about some of the results from our randomised control trial that we ran in Exeter. I'm going to give you a brief introduction, followed by the aim as well as our methods, the results from this part of the trial, some of the limitations, and the conclusion. Most total knee arthroplasty does well. Alignment and balance of the components in total knee arthroplasty is critical to kinematics. With manual instrumentation, there are two techniques commonly used: measured resection technique, a gap balancing technique. The aim of our study was to compare the femoral rotation of the total knee replacement using two different philosophies for alignment, one being a traditional measured resection, the other being an individualised alignment philosophy using an intraoperative gap balancer. In terms of our methods, it was a randomised controlled trial. Patients were recruited from the waiting list of 4 different consultants in the department, and the inclusion criteria were skeletally mature patients that were listed for a TKR using the Corin Ltd knee and were able to consent for the study. Looking at the implant itself, it's a cemented implant. It's a single radius of curvature. It's a cruciate retaining, although a posterior stabilised PS version is available and wasn't used in this trial, it was only CL. And the patella was resurfaced in every patient in our trial. In terms of our gap balancing technique, the tibia was cut first, then this proprietary equibalance device you can see was used to cut the distal femur parallel to the tibial cut in extension. Axial femoral rotation was then set from the tibial cut, balancing the knee in flexion. This was all done with the intention of preserving the soft tissue envelope. In terms of our measured resection technique, traditional, cut the tibial first in 0 degrees, distal femur was cut 5 degrees from an IM rod, and femoral flexion cut was made 3 degrees of external rotation to the posterior femoral condyles. Subsequent soft tissue releases were performed as required. In terms of imaging, we had pre-op CT scans to assess the native knee geometry, and these were repeated post-operatively. These scans were analysed by 2 blinded independent observers. The primary outcome measure was intra-observer reliability between the relationship of the Anatomical Trans Epicondylar Axis and the Posterior Condylar Axis on both pre- and post-operative CT scans. And secondary outcome measure was to compare the femoral rotation between the 2 groups post-operatively. In terms of our results, the CT scans were analysed for 92 patients in total. The intra-observer Pearson correlation coefficient was very high for both measurements. There was no significant difference preoperatively between the 2 measurements in either group. Post-operatively, the implant tended to be more externally rotated in the measured resection group. However, this wasn't statistically significant. In terms of limitations, there were only 46 patients in each arm. The epicondylar anatomy is quite variable sometimes between patients, and there was some degree of metal artifact occasionally on some of the scans. In conclusion, the Anatomical Trans Epicondylar Axis appears to be a reliable landmark to measure femoral rotation on CT, and the MR and GB alignment techniques produce similar femoral rotation. Thank you.